In this video, learn how to wrap C++ classes for Python using PyBind11, a crucial skill for integrating C++'s performance with Python's flexibility.
Welcome to an exciting journey where we explore the seamless integration of C++ and Python using PyBind11. Have you ever wondered how to combine C++'s raw power with Python's simplicity? This video is your gateway. We'll take you through the process of creating Python bindings for C++ classes, a skill that's pivotal for any developer looking to enhance their cross-language development capabilities. Whether you're optimizing performance or leveraging Python's libraries, PyBind11 is your tool of choice.
PyBind11 is an open-source library that serves as a bridge between C++ and Python. Designed for modern C++, PyBind11 allows you to expose C++ classes and functions to Python with minimal boilerplate code. Its compatibility with Python 2 and 3 ensures you can work with legacy systems while leveraging the latest Python features. By the end of this segment, you'll understand why PyBind11 is the preferred choice for developers aiming to harness the strengths of both languages in one harmonious environment. Before diving into coding, setting up your development environment correctly is crucial. You'll need to install a few dependencies, including Kmake, to build your PyBind11 modules. Ensure your Python and C++ versions are compatible. PyBind11 works with Python 2 and 3, but it's always best to use the latest versions for optimal performance. We'll guide you through integrating these tools with your favorite IDE and how to troubleshoot common setup issues. A smooth setup lays the foundation for efficient development.
Let's start by creating a simple C++ class that will bind to Python. We'll define a basic class with a few methods to illustrate the process. As we write our class, we'll include necessary headers and implement some simple functions. It's important to test the C++ class independently to ensure it functions correctly before binding. This step is crucial as it allows us to focus on the binding process without debugging C++ code.
With our C++ class ready, it's time to write a PyBind11 module to wrap it. We'll start by including the PyBind11 headers and defining the module structure. Our goal is to expose the C++ class, along with its constructors and methods, to Python. This requires careful attention to PyBind11's syntax, but don't worry, once you get the hang of it, the process becomes intuitive. Compiling the module without errors is our final checkpoint for this block.
Compiling your PyBind11 module is a critical step. We'll configure the Kmake list.txt file to ensure all dependencies are linked correctly. Using Kmake to build the module, we'll address any compilation errors that arise. It's essential to link the libraries correctly to avoid runtime issues. Once compiled successfully, our C++ class is now available as a Python module, ready for use. This step marks a significant milestone in our integration journey. With our PyBind11 module compiled, we can now access the C++ class in Python. We'll demonstrate how to import the module and create instances of the C++ class within a Python script. Calling C++ methods from Python is straightforward, but handling exceptions and errors requires attention to detail. We'll explore how to leverage Python's dynamic features to enhance the functionality of our C++ class, making the most of this powerful cross-language integration.
Binding complex data types and class hierarchies presents unique challenges. We'll learn how to bind C++ STL containers like vectors and maps, making them accessible in Python. Wrapping complex data structures requires a deep understanding of both languages' data models. We'll also discuss how to handle inheritance and polymorphism, exposing complex hierarchies effectively. The goal is to optimize for performance while maintaining Python's ease of use.
Debugging is an inevitable part of development. We'll explore common issues you might encounter when working with PyBind11 bindings. Identifying typical errors and understanding debug symbols can save you hours of frustration. Checking module paths and resolving linking issues are also crucial steps. We'll learn how to optimize error messages to provide clear insights into what's going wrong, allowing you to fix issues efficiently and continue developing seamlessly. Congratulations on reaching the end of this video. You've now mastered the art of seamlessly binding C++ classes in Python using PyBind11. Remember, practice makes perfect, so don't hesitate to experiment and explore further. We invite you to ask questions and provide feedback in the comments below. If you found this video helpful, please like, share, and subscribe for more content. Your engagement helps us create better educational materials. Thank you for watching, and happy coding!